Yeah, yeah, yeah. Mhm.
We could also have, we're going to order, we're also going to order, I'm ordering up to either an animal or another one. Small ones. It's true. All right. Sorry about the random. We're oh shit. I need to get my cord. Hold on.
Okay.
I can hear you though. So
Okay,
talk to
okay.
me. Talk to me, buddy.
Um,
How's quarantine treating you?
oh, not bad. I'm still at Cambridge. Are you still at Cambridge or?
Yeah, we live over by Grantchester Meadows.
Oh, right.
Like in Newnham on the walk out to Grantchester. So it's actually pretty good. There's a lot of people around walking, but we're okay. We don't mind it.
Yeah, I'm still at Fitzwilliam. So yeah.
Okay. But it's working out all right?
Yeah. It's good.
Good. And you're getting food and all that stuff?
Yep. I have fuel ordered.
Perfect. So you don't even need to eat. Did you have any questions about the assessment that we're going to be carrying out and all that process? While I've got you, I can maybe answer any questions.
Yes.
You got any?
Okay, so just to confirm, so there's no Viva happening, right? It's just a project.
No, there will be.
Oh, there will be.
There's the option for a Viva. So
okay.
We've not said one way or the other that there will or will not be. We're most likely going to have. They would not be in person, obviously.
Okay.
But my guess is we're going to probably have a few more Vivas than usual, if necessary. But at the same time, it's totally up to the examiner. So he might just say, no. He did it last year and he did like 6, I think, but they weren't, I sat in on one of them. Really friendly, really easy. So he basically was just like, tell me about your project. Tell me what you did. What did you think of the course?
Okay.
Did you think the modules were well run? Like it wasn't, draw the electron transfer and draw photosynthesis. It was nothing like that.
But but project presentations, they're different to Vivas, are they? Or
yeah. Okay. So a Viva is going to be a Viva is a sit down with the examiner.
Right. Okay.
So that's going to be a very different animal. You're going to basically just be asked questions. Typically, it's to try to figure out grade boundaries. So when people are sort of in between a boundary or on a boundary, then they might call you in. He also tends to pick people from like the middle of the boundary, like each of the middle of the groupings, just to know like, yeah, that's a 2-1 style, or that's a better style,
Right. Okay, so, but there's no project presentation, right?
No, there will not be a project presentation.
Okay.
Those were canceled. We emailed that to you already.
Yeah. Just make sure. Okay.
Yeah.
Okay, and the assessments, I guess, they'll be on, like, you'll type on Moodle, and yeah, that's it, right? So it's just literally.
Yeah.
Okay.
So we're gonna give you we'll give you more instructions later, specifically what to do, because I'm actually sitting in front of me on a tab is the rubric for the cover sheet for all the exams for 1A and 1B,
okay.
as well as for part 2 across the school. And we're waiting for information from the university on how to organize it.
Okay.
But you're most likely going to have to type it into a Word document, and then you'll upload that Word document, and then you'll also take pictures or whatever of images if you have them, and you'll upload those.
Okay, yeah, so that's totally what I expect. So yeah, that's fine.
Yeah, it shouldn't be. I mean, for someone who's tech savvy, right? Yeah.
Yeah, it shouldn't be too. Yeah, it's fine. Okay. Yeah. Okay. That's fine.
I mean, they're open book, right? So it's a little different than usual. So you're not going to memorize anything, right?
Yeah.
And you're also going to you're told to work for a certain amount of time, but you can clearly you're going to have 24 hours.
Yeah. Yeah, but they'll impose a word limit, so like everyone's gonna have to be more selective with
the word limit will be enforced. The word limit will be enforced. Pretty harshly, because we don't want that.
Yeah. Yeah, that's fine. That's fine with assessment. I'm not. I don't have further questions with assessments for now. So yeah.
All right, good. Let's see here. Cool. Anything else in general? You're good?
Yeah, in general, it's fine. I was just wondering what you thought about my.
Oh yeah. I'll take you through in a second. Oh no, it's Tim. Hold on one second. I've got a pressing email that suddenly just came across here. CDB is not giving the lectures.
Oh, right.
There's a panic from a few people. All right, cool. So we get these panic emails that fly through.
Right.
Which are mildly frustrating. Cool. So yeah, here's some feedback. So I got some stuff to say here. So that's good. All right. So I've got the document in front of me. So I'll just give you some comments and then you go from there. So just, put the actual word count on. It's the first thing to highlight.
Yep.
I thought the table of contents is great. I thought that makes it look very professional. So well done. You, in the abstract as well as the introduction, you sort of jump right into it. So you could, in theory, try to have a slightly more, lead us into it a little bit more. So you don't have to, but the idea that you just jump right in with biophysical properties of P-bodies in Drosophila is really narrow. So if you could have a sentence or even two sentences, how cells are organized is really important for their function. And one way this can be done is through phase separation, and then you can get into the physical properties, something like that, which brings us to this point a little easier. Especially because somebody else is going to read this who doesn't necessarily know much about any of these topics.
Right. Okay. So flesh it out more at the start of the introduction, flesh it out more a bit. Yeah.
Well, so the introduction as well. So I mean, it's if you can put a little bit more before you hit, biomolecular condensate. So I mean, what would you consider something you might want to put in before that?
Okay, wait. Let me just look at it here. So I start with biomolecular condensates. Formation of biomolecular condensate biological systems requires phase separation. I mean, I do explain biomolecular condensates, and
You do. So my question is, as an introduction, what might we want to hear, right?
uh,
I mean, what is the biological part that you're thinking of?
what, like, okay, I thought biomolecular condensates was already like broad because we start from biomolecular condensates and we zoom into p-bodies. So something broader than biomolecular condensates.
Well,
It's hard to think.
what's the biological role of a biomolecular condensate?
It's a biological entity that is the net result of phase separation.
Okay, but
It's the net result of
why do we want to?
proteins, RNA
Why should? But hold on. Why
interacting.
should I care about? Why should I? My name is Torsten Krut. My name is Howard Bayless. I'm Matthias
Okay.
Landgraf. Suddenly, why should I care about biomolecular condensates? I've heard of them, but they're just getting published, and I don't get it. Why should I care
Okay. So
about phase separation?
you mean like care from like a human centric point of view? So like they could
Well,
be
no, but I mean,
involved with like disease or something, or you
sure,
mean?
sure. That's a good point. What about like I'm a cell biologist who works
Oh, okay.
on
I see.
DNA,
Yeah.
or
I see.
I'm a
So
cell biologist who works on neurons, right?
yeah. So in terms of biomolecular condensates, you can sort of link it to like translational regulation. I I think
Yeah,
so.
that would be a good place.
So like depending on the phase, they could be differently regulated translationally. So that's could I say that to like link it to importance, sort of.
Yeah,
Okay.
absolutely.
Uh, okay, cool.
I mean, if you can start off with, you know, if you can start off with something that's a bit more, uh, oftentimes RNA is a good way in. So,
okay.
you start off with something big like, RNA regulation is essential in all cells. One way in which RNA can be regulated is to separate it from the ribosomes or have it associated with specific proteins. One type of association would be a biomolecular condensate. These condensates form, and then you're off and running. But it brings us up to speed.
Mm-hmm.
And then your point about human beings is a good one as well. So as you get towards sort of the end of that section, you're getting into C. elegans and zebrafish and so forth. You could mention something about human beings there, or just a sentence or two early on,
Mm-hmm.
because that's important to just make it. It makes us all as readers feel like it's motivated.
Yeah. Okay. Mm-hmm.
Good. And then you sometimes use the biomolecular condensate stuff at the fourth paragraph. There is good. You're then transitioning into P granules, which I think works pretty well. Just as a side or like a note, the second paragraph of the P granules and C. elegans section, the Putnam et al. 2019.
Uh-huh.
Typically, we just put the reference at the end of the paper or at the end of the paragraph or the end of the sentence.
Okay.
So yeah.
So how would I say it? Because I want to say this person subjected P granules to a series of different conditions.
So then it's not this person. You say,
this group or.
Well, no, not even the group. You say to test, right?
Sorry.
What were they testing? The to test, right?
Oh,
so
I
to
see.
Test if
okay.
P granules this, they did the following things were done, and then you put their reference.
Okay, cool.
I mean, you said it before, using fluorescence recovery after photobleaching, they showed, instead of making it like it should be using fluorescence, like fluorescence recovery after photobleaching shows that P granules exchange components with the cytoplasm, period, right?
Okay. Uh-huh.
So you do this again later, which is one of the things you sort of say, like, next I decided to, or I decided I would like to.
Uh-huh.
You're sort of making it read more like a narrative, which is, we talk about narrative, but that's a little too far. We would say, in order to test blank.
Okay,
I used.
Wait, sorry. So the voice, so like the passive voice or the first person voice, like which one? So are you saying I should
You can use a first person voice,
Okay.
but you don't want to like start the sentence with it. You want to start it with the question or the experiment,
Okay.
and then you can say I did, or I used, or I show. That's fine.
Okay.
We'll get to it a little bit later, but there's an example here. I'll find one in the like I counted particles smaller than 0.35. That's not really what we'd say. So
Okay.
say
Okay.
it would be like particles 0.35 or smaller were
Okay.
da 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 da.
Okay. Cool. Yeah.
All right, so hold on, let me get there. All right, good. So yeah, I thought your paragraph about Drosophila Peabody's, going back up. So the end of the C. elegans bit, it says this shows the P granules can primarily break down in response to high cell concentrations. That's good. You could do some type of conclusion there, but I think that is a nice, that does conclude the section to an extent, which is good. You're giving a lot of detail in this. So one of the things you do is you're getting to it might be important to give the molar, NaCl, or to give the, how it's the GFP label. But you can just say that, for example, the PGL3 GFP, you can say they found, well, it would be PGL3 liquid-like phase separation dissociated upon extrusion. You don't have to say it was marked by GFP and then fell apart. You can just say it falls apart.
Okay.
And again, getting rid of the they found, right? It's just PGL dissociates upon extrusion. Right? And then MEG3 persists in high salts. We don't care if it's a GFP or not.
Yeah, okay. Yeah, I think I'll use they found something like that quite frequently, so I'll change all that.
Yeah, cool. So then with Peabody's and Drosophila, that's a good start. You're now saying some experimental conditions for those used in the experiments, right, can be applied. So you don't have to say by Putnam at all. It's just similar conditions, experimental conditions can be used for to investigate, Drosophila Peabody's, period.
Wait.
So the first sentence of Drosophila Peabody's.
Okay, similar experimental conditions for those. Okay, yeah. That stuff? Okay.
Yeah, you can say similar experimental conditions used to test P granules can be applied to Drosophila Peabody's.
Okay.
Yeah. The end of that paragraph, like the last paragraph in that section is really good. I thought there's a lot of really nice detail there.
Okay, cool.
Possibly too much, but pretty good levels of detail.
Yeah.
When you hit egg activation section, you might want to give us a bit of a transition. So you've been talking about Peabody's and Drosophila. So is there any way of, is there anything you could sort of, maybe you're talking about things changing, or just, one of the major changes that an egg will undergo is activation. This is going to alter many properties, and then you can do something that links back to the paragraph before.
Okay.
You're not alone. A lot of students commonly do this, where they just use a transition as a
right. Okay.
The transition is the statement there, which isn't really what we're looking for.
Okay, so link it back to the Peabody paragraph a bit more.
Or any biomolecular condensate, because it's a pretty hard, it's a hard right turn.
Okay.
Yeah, does that make sense?
Yep. I do have a question. I said Sankar 2020 unpublished. I didn't really know how to properly reference.
Yeah, you write personal communication.
Okay. So you just do
personal communication.
Parentheses personal communication or something like that, or
yeah, personal communication unpublished.
Okay. Cool.
I thought your aims were good, and it's nice to see a very direct aim. So well done on that. Yeah.
Okay.
Good work there. So your materials and methods, I think you're covering most of what we want to see, which is nice. I thought, getting into the different images, I actually kind of appreciated being able to see how they all worked and what you did. It is a little confusing at times where you say something like cleaning, So manually cleaning of the threshold.
Yeah.
It'd be good
It's
to give a little more information about what that means. Yeah.
okay. Cleaning's like literally like cleaning of the image, like
Yeah.
because
No, no.
sometimes
You don't have to explain it to me. You just have to explain it to your reader.
yeah.
Because
Okay.
your reader probably isn't going to be as well versed in some of these terms. So it's useful. It's useful just to sort of ask about that. Yeah?
Okay. Explain cleaning more. Yep. Okay. Cleaning more. Okay. Cool.
Well, and just like the title of it too, right? It just says cleaning. I'm like, what the hell is this talking about?
Cleaning's a bit ambiguous.
Yes, I would say that. I mean, I liked figure 2 a lot. I thought that looked really cool, and it's a nice difference between the two.
Okay. Cool.
Yeah, I mean, there's a lot of really good detail. I thought it was interesting, and it does show that you've done it. So that's an important step as well. So with the results, I mean, the main suggestion for your results section, you've got a lot of figures, lot of figures. And what tends to happen is the text is sort of broken up in a very direct, like, here's the details of what I did. But there isn't necessarily like the motivation for each of the experiments or like a thread that connects them, which is fine because that's what your second, and third rounds of editing are for. So, when you start a section, you need to give us a little bit of a setup, right? So instead of just the effective temperature on P-bodies, and you jump right in at the molecular level, temperature breaks Van der Waals forces. Okay. Could you give us a little bit more about, why are we interested in this? How does this relate to your aim? Usually go back to your aim and say, like, in order to test, the effect of changing properties, on these structures, I exposed them to different, variables. The first was to test this, and so it's something that at least brings it a little more home to us, I suppose.
Okay.
I mean, the same thing too. Then there's another section very quickly, that's saying the effective temperature on P-body shape and texture. Why do I care about shape? Why do I care about texture? Like, why does this matter? And I think you need to continue to link yourself back to the overall, why are you doing this, right?
Okay, cool. So always link back.
The why are you?
Yeah, okay.
So that's why it's important in your introduction to say, why is this important, right?
Okay.
If you can say why it's important, that's really going to be critical. And then every time you go to a new section, you typically want to sort of link it to the section previously, right?
Okay.
You also have a lot of, generally speaking, you have a lot of detail in your text. So I realize sometimes you want to tell about temperatures, but if we really want to know, like, the gene, it's ME31 GFP, and we want to know the range of temp, we could probably we'll look in the figure for that. So if you can kind of keep it slightly broader in the text, that makes it a little easier for us to follow.
Okay.
That's going to be the case a little bit later on. You get pretty deep into the weeds sometimes.
So in the text, if I don't have to mention like ME31B, GFP that many times.
What I would say is, have you introduced ME31B yet? I don't know.
I think I do in my introduction. I mentioned it.
So here, you say something like ME31B is used as a marker for P-bodies. You don't have to say it's a GFP. That doesn't matter.
Okay.
And then you're going to test it at different temperatures. What you find is that at a higher temperature, it takes on a different structure. And then you say, parentheses, whatever figure that is, figure 4. Then if I want to know what the different temperatures are, and if I want to know what the increments are, and if I want to know for how long you incubated it, all of that information is in the figure legend.
Okay.
So what it means is, instead of saying, as shown in figure 4, and then P-body morphology changes from 25 to 30, from 35 to 36, from 38 to, all of that is, I want to know what the overall take-home message is.
Okay.
Right? And that'll give us a little bit more of a narrative that runs through it. And that then links nicely if you can go to your figure legend, and then the first part of your figure legend is a bold title that says, P-bodies change shape with increased temperature, period.
Okay.
Or whatever it is.
Yep.
Yeah. So you're saying Me31B GFP Peabody shape changes after 10 minutes post heat treatment at 40 degrees. So, Peabody's changed shape at a higher temperature, period.
Okay.
Me31B GFP expressing fly, was incubated for 10 minutes at this, panel A. Arrows show the difference, right? So then you highlight the arrows are showing a change in the shape. Yeah.
Yeah.
And that's in the figure legend. And then you can, then the next step is, you wanted to know how circular they are. So in the text, then you say, having seen a change in the shape, I wanted to then quantify how much the circularity was changing. And then tell your reader, circularity is often used as a mark for phase.
Okay.
Yeah. So things like that and then, figure 5.
Yeah.
Okay. You say circularity is often used for size. I found, right, when analyzing circularity, I found that post-incubation, it was statistically more circular, which suggests that it's changing phase or whatever it is, right? And then you say figure 5. And then all the details of it are in the figure legend.
Okay. Yeah.
So then that sort of links together, and then, you can say, the other way to actually do this would be to structure and say, once you saw there's a difference, you say, in order to really understand what this change in shape means, I did a number of analysis steps, including, I did a number of analysis steps, and then just take us through the different analyses.
Okay. Yeah.
Because a lot of what you're doing with the analysis of the backgrounds, all of those things, you just need a sentence or two to tell us why you did it, and then what does it tell you, right? Because it's really, you've got a lot of really cool data, right? It's just about making sure we reach it.
Yep.
It reaches us. And then like between figure 8 and 9, there's a bit like, it's a sentence. Incubation of Peabody at 40 degrees is generally small fusion particles. They're most prominent compared to temperature 9. Like that's 2 figures in one sentence, and I'm not really sure what I'm supposed to be gaining from this, right?
Okay. Yeah.
So if there's a way you can sort of, more, you basically just need to explain what you're showing us a little bit more direct. Again, think about this as someone who doesn't know the field at all, right?
Okay.
Does that make sense?
Yeah. Incubation Peabody 40 generates particles. These are most prominent.
There's another example on page, what is this page? Page 15, where it says, I counted particles smaller than, like we talked about before. You really just you don't need that much detail, right? Okay. I completely tuned out when you say smaller than this size for this area for these 5 temperatures and then did these in R. Like, I don't care.
Okay.
I want to know what the take home message is.
Yeah. Cool. Yes, I'm just writing down what you're saying, so sorry if I'm not like...
Yeah, it's good. No, that's good. That's good. When you said there's a section on page 16, effects of cooling on fusion fusion particles or on particle fusion, I thought the fusion particles produced, so that's a little too like colloquial. So, I thought, so, one hypothesis is that kind of stuff.
Oh, okay, yeah. So, that was not well, that part was not well written. Okay.
Yeah, just professionalize that a bit. You do the same thing on the page 18. It says, I would think that. So,
okay.
one interpretation is like that kind of thing.
Okay.
Right. Again, like your figures, sometimes they have titles on them, sometimes they don't. Like, one of the things to do is just put the title as the first bit right after the figure, right? So you can tell us, we can look at the figure and know exactly what we're seeing.
Yep.
I think is it page 19 where you're talking about the monovalent salts. So again, I wanted to test, in order to test these different things. you give like the second paragraph there, that's a ton of detail again, right? So it's just way beyond what we would need in the actual text. We want that in the figure legend. We want the text to be much more flowing.
Cool. Yeah, all those like statistical details, they should be in the figure legend and not the text. Okay, cool.
Yeah, absolutely. And you've got a ton of data. Some of it's better. Like figure 19, I appreciate that that's dissolved, but you may not, just because you've got 33 figures or 35 figures, whatever it is, you may not need to include every single one of them.
Okay, for figure 19, I can just say it dissipates rather than showing a figure. It dissipates. Okay.
Yeah, just say it dissipates. Full stop. Okay. Let me. This is going to cut off in a minute, so let me hang up, and I'll send you another link.
Okay. Sure. Yeah. Wait.
Can you hear me?
Okay, I can hear you now. Cool. Yep.
Great. All right. So let me see here. See, I think you're getting the sense of what I'm asking for here in a lot of the results is kind of the same thing.
Yeah.
Because you also have so many like data points, it's important to sort of, where you may need to trim down some of them. It's great to have this much analysis, but at some point it sort of loses the importance, because it's just kind of, you'll get penalized for being unorganized, if you will.
Right. Okay.
So it's important that you're able to sort of explain why each figure is there. And if it's not really an essential figure, you may want to consider trimming it out.
Okay.
But from our perspective, it's great to have this much analysis. It just needs to read more like a paper than a sort of list of experiments with all the technical detail.
Yep. Okay.
Yeah, changing. So, I'm on page 31 here. Unfortunately, a scale could not be added to the fluorescent images.
Yeah. I was probably going to remove that, but I just wanted, so I have some fluorescent images, and yeah, I cannot add a scale with a calibrated distance to it. Will I get penalized if I produce an image with no scale with it?
The other option is, if you can't, you don't have to include it, that image, right? You definitely are going to have to trim some stuff out, I think. So It's really up to you on which ones you include and which ones fit. You may want to just narrow the scope a little bit.
Right. Okay.
Yeah, it's going to kind of be up to you what you feel like fits most comfortably. I think the key for me is, if you break this up into two sections, one is about temperature, one is about salt, and then you really just drive home very clearly what's going on. I think that's much better.
Okay. Well, yeah, I can remove the MGCL2 trailer hitch because it's showing the same thing, just with trailer hitch. But
yeah, just say that then. I continue to do this, and I'm not showing that data for space constraints.
Yeah. Okay. Remove trailer hitch. Okay. Cool.
That works.
Yeah. So okay, that's the results. I think so.
Yep. Good.
Now
And then,
discussion.
I mean, when you get to the discussion, the key for the discussion is you're spending a lot of time, and this might actually be, you're kind of referencing all of your figures in the discussion.
Uh-huh.
So that's fine. You also have a figure in the discussion, which is always a little strange. Usually those figures are in the results.
Okay.
So I'm thinking about cutting that. But yeah,
Okay,
I mean,
okay.
the idea that you're kind of going through and saying, as seen in figure 4, and then this in figure, all of that really belongs in the results
Okay,
in a lot of
okay,
ways.
okay.
So you maybe already have your results section written, if
Okay.
you will. So that's part of what, what you really want to see in the discussion is you take the conclusions from your results and then you expand to discuss them in the broader context, right?
Okay.
So if there's a place in which, you could discuss how this is similar to a C. elegans, or how this is really, it's just like something that was done in vitro, or, you maybe found that salts are really important in vivo, but this is consistent with what's been found in vitro. And then you talk about in vitro work, right?
Okay.
So
Okay.
you're taking your data and you're putting it into the field rather than just summarizing your data again.
Okay.
So really your summary and all of this stuff, it actually might just fit very neatly into your results,
Okay.
to
Okay.
be honest. You typically don't refer too much, like you're not going to go through each of the figures as much as the concepts. So at the end of each of your results section, you might have a conclusion. And at the end of that, that conclusion then will follow on quite nicely to then be what you discuss in the discussion.
Okay. Okay.
But when you get to, I mean, the other thing is like I enjoyed some of the discussion of the methods. I thought that was actually quite interesting. I'm not totally sure it belongs, but I suppose, it almost felt like it was in the method. It should be in the methods.
Okay.
But it's up to you, because there is a sense of you're doing a lot of technical challenges and you effectively design a way of analyzing this, which is great. And then you want to discuss why you made those decisions. I think that's fair, but it has to fit in with the context of, would it be dramatically different if you did a different analysis, or would it be different if you took a different approach, right? So you need to just make sure it stays with the overall sense of what you're trying to say.
Okay. Okay.
So you can't just discuss the method for the sake of discussing the method.
Yeah. Okay. Okay.
Right? I mean, when you get to, future experiments and conclusions, that's good. Now you're hitting us with something, right? They could be a little general. More future experiments would be good, and maybe not necessarily quite as specific.
Yeah.
You might want to also test ATP. That's great, but like what else? Like that's, you can think really broadly. You could even expand some of this, to other systems or other cells. You really have the freedom in the discussion and you should be making this not just about Drosophila.
Okay. Okay. Not just. Okay. Okay.
I mean, what you've done is a pretty common. I mean, students who get a lot of data and are doing a lot of analysis want to include everything, and they want to sort of tell us everything they did. But at some point, just like the presentation, you're actually going to be damaging the quality of the report by including too much data. So you just have to figure out, and doing the analysis is good because it gives you a sense of what the answers are. But you do need to sort of stop yourself at some point so that your reader doesn't just throw their hands up in the air and say, well, this is just way more than I can deal with.
Yeah, I know. It's a bit difficult because like the nature of the project itself is sort of like, it's characterizing the biophysical properties of P-bodies. So it's more on like quantitating. So
that's Brendan, that's fine. It's really, again, you're partially being marked, or one of the marking criteria is about organization.
Mm-hmm.
One of the marking criteria is about logical and concise and easy to follow, right?
Mm-hmm.
And that is a pretty large part of a presentation like this as well. And go back and review what we're actually marking you on. We need to mark you on the clarity of the write up, right? The quality of the write up. You're not being marked on the data. So in zoology, again, you're not going to be marked on the data you present. We're going to be very interested in what you've got, and it makes for a better report. But you're not going to benefit yourself by including all of the data. It'll really lead to the detriment because it does become distracting. And without a thread connecting each of the sections, and without motivation between each of the experiments, your reader is going to be very lost. Yeah. So you really want to ask yourself, am I connecting these experiments, and have I motivated this paragraph?
Yeah.
And this might mean, cutting. If you've already got a lot of words, it might mean cutting, some of the experiments, quite a few of them potentially, and saying, and you can say, I did, this analysis, this analysis, this analysis, and this analysis. Because of space, I'm only showing you the first one.
Okay.
However, they are all consistent. The thing that's missing is you need to say they're all consistent with a change based on temperature, or they're all consistent with monovalent salts being important for Peabody structure. It has to come back to what is this building as a model, and then why should we care as biologists? So yeah, it's just a little too in the weeds. You definitely need, just keep asking yourself if a mouse biologist read this, or if a DNA biologist read this, which somebody will, how are they going to interpret it? They need to be able to see why it matters, because you've got some really good data, and you've got some good things to say, and you've got some really nice conclusions to draw, but you just need to make sure the reader gets there without being too exhausted. Yeah.
Okay, so just motivate, for every single experiment, just need to motivate it, have a motivation for it, and link it to previous experiments, and make sure they all connect to a theme. Yeah. Okay.
Yeah. Well, the overall, why did you do this, right?
Yeah. Okay.
And don't forget, you didn't do this just to count Peabodys, right? There's a broader sense of what's important here.
Yeah. Yeah. Okay. I do have okay. I wonder if I can screen share, because I do have a figure, sort of it's a speculation on the possible Peabody structure. So possibly the Peabody could have a gel peripheral edge, and then a liquid core.
Yeah.
But I'll just show you. Hang on.
Just hit the bottom on the bar. It says share screen. There you go.
Yeah. Wait. Can you see it? Or?
Yeah. I see it.
Wait. So a figure like this. I don't know if I should include this or not, but I'm just wondering what you think of it. So.
Yeah, that's fine. I prefer to have something visual to look at. So I do think that's useful.
Okay.
And Brendan, this is the perfect thing to put at the beginning of your discussion, and just say, my data. The data presented here suggests the following model, and then talk about your model for a paragraph or two, right? And that's showing us this is the model for me to tell you about.
Okay.
So I don't need to recap all of the 35 experiments. You just need to now discuss what all of these experiments tell you. So this will give you a nice structure. So I would say, yes, that's a good step.
Okay, cool. Yeah, that's so okay. I can talk about this in my discussion. This is a possible model of Peabody structure based on my data. Okay, cool. Yep.
Good.
Cool.
All right. I mean, you've got some work to do, but at the same time, you've got some really good stuff, and focus on just trying to make this, like I said, motivate it, but also make it a little easier for your reader to follow.
Okay.
And think about non-phase separation, non-Peabody people. Yeah.
Okay.
Because if you think about them, you might say, "Ooh, that is hard to." Yeah. Ooh, I think I lost it. That kind of thing.
Okay. Yeah. Cool. Mm-hmm.
Yeah. Brilliant.
Wait, sorry. I just have just a few more small questions. So, okay, my methods. Do I need to mention the numerical aperture of the Olympus microscope? I mean,
you can, but it's not. I mean, you can, but no one's going to check you on it.
Okay. And so table contents don't count towards word limit, right? Or they?
No, they do not.
Okay, cool. And is it worth mentioning like the whole like COVID-19 situation? Like, is it worth mentioning?
No,
Like, so just cut it
no,
out.
cut it.
Like, not saying
You,
okay, like because it's sort of. I mean, it did disrupt most people's experience as well, but
it disrupted everyone, and it
yeah.
disrupted everyone in different levels. It's not worth worrying about. Save your
So
word count.
so okay, don't mention it at all. Okay, cool, cool.
Don't mention it at all. You're gonna need those words, my friend.
Okay. Yeah, that's most of. Yeah, that's all of my questions. Okay,
Right. Good.
cool.
All right. Well, good luck. You'll get
Okay.
there. Okay.
Thank you. Thanks a
No
lot.
problem. Take care of yourself.
All right, you too. All right,
I'll see you soon. Bye.
bye. Thank you.